So the last unit we study in pre-calculus is this thing called a matrix. And a matrix is just an organizational tool that we use, and really it represents linear equations. And so we actually have a college course called linear algebra. So it's doing algebra on linear equations, and we use matrices a lot in there. Matrices are a lot of applications in computer science. It's kind of how we know how to turn on a pixel or not. It gives us a location. And we can do a lot of transformations with them. That's why it's good in electrical engineering. So it's just a good organizational tool that's very helpful and useful. So a matrix, another way that some people refer to it, is an array. And it's an array of numbers. When you learned how to multiply and stuff, you made arrays. Arrays is just an organizational thing. Just like in Google Meet, you have an array of that 9 little dot thing up there at the top where you get into your Google Meet. What does that look like? Well, it's going to have these things going down this direction, which we're going to call columns. So columns go down and rows go across. So this would be row 1, this would be row 2. And we would put it in this little brackety thing. Okay, so matrices are arrays made of rows and columns. Rows go across, columns go down. Kind of a little bit of reverse of what you would think. So we name our matrices. Typically, we just use capital letters, so forth, to name them. They have dimensions. Dimension is the size of the matrix. So if I'm looking at the matrix up here and I want to give it a size, the size is a parenthesis. You name the row first, the size of the row, times the column. You don't actually multiply them. That's just the size of the dimension. So in the matrix above, I have 2 rows and 3 columns. So these are parentheses. It somewhat looks like an ordered pair, but we're going to put an X in there so it doesn't look like an ordered pair. So it'd be 2 by 3 is how we would say that. Again, very important you recognize that this is a row and that is a column. Okay, so we have some special matrices. Well, one special matrix, I'm just going to use X's in the place. Holders. That's a square matrix. Can you see why we call it a square matrix? We have a row matrix. I could put more X's in there if I would like, but that's called a row matrix. We have the zero matrix. Just has a bunch of zeros. And since I have a row matrix, guess what I also have? I have a column matrix. And so what we're going to do with these matrices is we're going to tie them into vectors and trig. So we need to be able to identify these matrices. So it's kind of like a little bit of a battleship game. So if I'm looking at this first position, this is in row 1, column 1. And that's typically how we'll say it. Okay? Or sometimes we'll write it as with R and a 1, 1. Okay, so the next position is row 1, column 2. And the next position is row 1, column 3. So moving down here would be row 2, column 1, and this is row 3, column 1. And it would just keep labeling that way. So this next position, I'm still in row 2, but now I'm in column 2. Okay, so this would be row 2 still, but now column 3. So we have an identifier that we can use. We'll practice here in just a minute. We can do operations on matrices, and just use your intuition. If I look at these matrices, this one, let's see, we put rows first, 2 by 3. And this is a 2 by 3. So I can add these matrices. So what I'm going to do is take their entries, corresponding entries, and just add them. So this 2 gets added to the corresponding entry in B. When I add those, I get 2. And likewise, negative 1 gets added to 4, which gives me a 3, and 0 plus 5 is 5. Row 2, add those elements, or entries if you will. 4 and 0 is 4, and negative 3 and 1 is negative 2. So then we close up that matrix. Make sure you put the bracket. So since we can add matrices, well, we can all subtract them. So again, I'm taking these 2 minus 0, and negative 1 minus 4, 0 minus 5. 3 minus negative 2 would be a positive 5, 4 minus 0, and negative 3 minus 1. And now none of these numbers probably mean anything to you, like why would we ever add matrices or subtract them? You'll kind of see some applications, but we'll just touch on those right now. So in order to add matrices, it looks like the matrices have to be the same size. So they have to be the same size to add or subtract. I have to have that element added to another one. I can't just put it in there. It's got to be combined with the other matrix, so that you can only add when they are the same size. We also have this thing called a scalar product. Scale means enlarge or shrink. So a scalar product says, I'm going to take k times a. That's what it would look like. Here's my constant k, and it's going to be multiplied all by a. So that means every element or every entry is going to be increased by 3. And hopefully that's somewhat intuitive for you. You may not have seen that before, but maybe when you see like, oh, k times a, that just means the whole matrix is going to be multiplied by k. So we're going to do some applications of these here in a little bit to show you what they actually do to a vector. The next operator multiplication is going to be its own video because it has a little bit of a twist to it, so we want to make sure we have enough time to show you that.